Hello, this is Mrs. Ringrose, and I want to start you off with taking some vocabulary at home as part of your homework so that when you come back to class, you're ready to go for the hard stuff. All right, so some of these words you may know, but it's good to refamiliarize yourself with it or at least know the preferred geometry definitions. So I'm just going to go ahead and give you some of these definitions that you may be able to get from your textbook, or if you'd rather listen to me explain it. Here we go. All about angles. Yay! What I need you to be able to do is name an angle. It's super important, just like we named line segments and lines and planes. You have to be able to name it correctly. I want you to be able to measure it with a protractor in class, and then I want you to be able to classify it by its degree measure. So first of all, an angle is basically two rays with the same end point. All right, and I'm sure if I asked you to, you could all draw me an angle. Here's ray number 1, here's ray number 2, and they meet with the same end point. The sides of the angle are the rays. So we're going to go ahead and label this aside, and I'm going to label this aside. Lastly is the vertex. You may or may not have heard this word before. The vertex is a fancy word for the corner. So in this case, the vertex is the end point of the rays. Okay, so let's just make sure we got that word on my labeling too. So we have the two rays come together, you have the two sides, and that makes our angle. You can always pause me and go back and make sure you have the words correctly. That's what's great about having me on a YouTube video. All right, naming angles. Super, super important that you can do that. Because again, there was some confusion with the lines and line segments and rays. We really want to make sure that you can do this with good precision so that you are talking about the correct angle in any kind of problem. You have your easy example where you can go ahead and draw this in your notes. You can pause me while you do that, or you can do it quickly. Okay, you can, when there's just one angle, you can name this angle H. All right, sometimes I might throw a little arc on my angle symbol, so I apologize if I do that. I'm kind of been trained to do it that way when I'm handwriting it, and that's so that people don't confuse that notation with a less than symbol. All right, so we go with that. We can name it angle H. That's the easy way. That's like a shortcut. All right, you can also name this angle RHS. All right, what's important to remember is that you're putting the vertex in the middle. You have to put the vertex in the middle. Have to. We cannot name this angle HSR. All right, please don't do that. All right, but it doesn't matter which way you go. So you can name it angle RHS, so you're going from R to H to S, and you're talking about this angle right here. Or you can label this SHR. Okay, notice again that the vertex is in the middle. All right, that has to happen. Okay, sometimes, just to make life really super easy, sometimes you'll see like a little number there, and then you can actually name it angle 3. That's awesome when that happens. I love it. All right, next one, you can go ahead and sketch this in your notes. You might have, this is actually an example in your notebook, in your textbooks. So if you want to look at that and read how they explain it, if you need further help, and I drew it a little backwards, but that's okay. All right, you cannot call this, you cannot name this angle X. All right, cannot do that. And you're probably already thinking about why. It's because there's different angles coming out of angle X. And you don't know if angle X is talking about this part, or the whole big angle. You just don't know. So when it looks like this, you have to be a little bit more precise, and we can call this angle ZXY or angle y, x, z, and that takes care of this little angle right here. Again, it doesn't matter which order you put it in. What matters is that you have x in the middle because x is the vertex. You can also talk about angle WXY or angle YXW, and that talks about the slightly bigger angle. It almost looks like a right angle. And then lastly, you actually have three angles here. You can talk about angle ZXW, or you can name that WXZ. And that talks about the big angle, from ray XY to ray XZ. All right, but you have to, for this particular example, you have to either use that name or you can use that name. All right. Next, there is something called the protractor postulate. It's in your books. It's similar to the ruler postulate. Basically, we're going to talk about the measure of an angle. And you're going to see that notation. Just like a line segment, you had AB, talked about the line segment, but just saying AB actually talked about the length. We have different notation to talk about the measure of an angle versus the actual angle itself. So if you want to talk about how big angle A is, then you talk about the measure of angle A. So you put that little m in front of it, and that means that you're talking about the measure. And you know what our degrees are from angles. 0 degrees, 280 degrees, most commonly. Sometimes you can talk about reflexive angles. They get a little bit bigger, but I wouldn't worry about that right now. So really what's important is that you know your angles from 0 to 180 degrees. The last thing I'm going to stick you with before we leave, and again, you can grab this from your book if you're done listening to me, but acute angles are your angles that are between 0 and 90 degrees. You all know this. Looks like a sharp angle. Acute actually means sharp. If you were going to the doctor because your tummy hurt, you might say that my pain is acute, which means it feels like someone's, you know, kind of stabbing you. That's nice and sharp. If you kind of have like a dull ache, you wouldn't call that acute. A right angle is when your angle is exactly 90 degrees. Your obtuse angle is going to be from 90 degrees, but not 90 degrees, not equal to it, but even 90.8 degrees to just under 180 degrees. And then, yes, we have something called a straight angle, which are actually two opposite rays. And this is exactly 180 degrees, makes a straight line. All right, so hopefully for next class, you're going to at least have this background knowledge, and we're going to go into talking about the angle addition postulate. It's similar to the segment addition postulate, but way more fun. Again, go ahead and review this to make sure you're all set, and if you have any questions, let me know. Thank you.